Hi, good morning. Today we're going to begin our first day of reviewing. So we are going to begin with limit. So let's take a look at part A. Part A, you have to find whether this statement is true or false. So limit as x tends to 4 f of x exists. Let's take a look at the graph. So x equals 4, we trace it from the left side 4, the limit is 5. And you trace it from the right side, the limit is 6. So we say that the limit does not exist because left hand limit not equal to right hand limit. Now let's take a look at number 1b. Is this statement true or false? Limit as x tends to 2 f of x exists. 2, you trace it from the left side, you go to 3, and trace it from the right side, also go to 3. So left hand limit equal right hand limit, so therefore it exists. So it's true. Let's take a look at part C. True or false? Limit as x tends to 3 f of x exists. So this one we go to 3 over here, there's a hole over here. If you trace it from the left side, you go to y equals 0. You trace it from the right side, also go to y equals 0. As long as they go to the same y value, so the limit exists, even though there's a hole over here. So for part C, the limit still exists. So don't forget to write correct notation. So one more time, don't forget to write a correct notation. This year we are not going to have multiple choice question. We only will have 2 free response questions. So the correct notation is very important. If you don't write it correctly, you will lose point. Now let's take a look at part D. Find the x value at which f of x is not continuous. Not continuous means there's a hole, there's a gap. So definitely it's not continuous at x equal 3 because there's a hole over here. And then not continuous at x equal to 4 because there's a gap over here. And here we call this a removable discontinuity because you had the limit exists but the y value is not the same. And this is called jump discontinuity because your left hand limit not equal to right hand limit. So for part D, at x equal to 3, okay, there is a removable discontinuity at x equals 4. That is a jump discontinuity. Let's take a look at part E. Find the x value at which f of x is not differentiable. Not differentiable. So let's see what I mean by differentiable. Differentiable first you have to be continuous at the point. And then the slope had to be equal. only these two satisfy, then the function is differentiable. Because this is a graph, so we can look at the graph and see where it's not differentiable. We look at the part where it's not continuous first. At 3 and 4, it's not continuous, so automatically it's not differentiable. And there's another point at x equal 2. We have a corner over here. Even though it's continuous over here, but we know that your left hand slope and your right hand slope are not the same, so therefore it's not differentiable. So for part E, the answer will be at x equal 3, x equal 4, because there are discontinuity at x equal 2, because there is a corner at x equal 2. Your left hand derivative not equal to the right hand derivative. So altogether there are 3 values. Let's take a look at part F. True or false? F of x is not differentiable at x equal to 1. Based on part E, you already know the answer, but let's take a look at what it means by horizontal tangent at x equal to 1. So for part F of x has a horizontal tangent at x equal to 1. So that means f of x has a slope m equals 0 at x equal to 1. Then that means f prime or 1 equals 0 exists. As long as the slope exists, then f of x is differentiable at x equal to 1. So the statement is false. Now we finished question number 1. Let's go to question number 2. Question number 2. F of x is a piecewise function. F of x has a horizontal tangent x equals 0. That means m equals 0 over here. F of x have a corner at x equal to 1, a corner. So it means when your left hand slope not equal to right hand slope. F of x has a cos at x equal to 2. So that means, okay, this one you're going to have a slope that going to negative infinity and the other side going to positive infinity. So definitely it's a cos over here. So at x equal to 1, f of x has a corner. At x equal to 2, f of x has a cos. So these are the 2 locations that is not differentiable for number 2. Now let's go to question number 3. Before we go to question number 3, the third time of discontinuity that we never put on question number 1 is called the infinite discontinuity. So this one, it happens when there is a vertical asymptote at x equal to a. So most likely you may not see this one in your AP exam because we only have 3 response questions, but it's good to know. Infinite discontinuity means there's a vertical asymptote. Let's take a look at question number 3. So question number 3, we had a piecewise function. So part A is f of x continue at x equals 0, justify your answer. To be continuous, we have to find the left hand limit and right hand limit, see they equal to the point value. If they equal, it's continuous. So we're going to begin. Don't forget to write the correct notation. So we're going to use substitution. So we're going to grab the cosine function. So we're going to get 3 minus 1 equal 2. And then we're going to do the right hand limit. So ln1 is going to be 0. So your left hand limit equal to right hand limit. So we're going to say limit x tend to 0 f of x equal to the same number 2. So the limit exists. So there's one more number we have to make sure they equal. How about f of 0? So this one part equals 0. So f of 0 basically do substitution. So it's going to be 3 minus cosine 0 again. So now we can say that the limit equal to the point value. So f of x is continuous at x equal to 0. Now let's take a look at part B. Is f of x differentiable at x equals 0? Differentiable had to be 2 condition. So 2 condition. 1. Continuous at x equals 0. 2. Left hand slope equal to the right hand slope at x equal to 0. So we had to meet these 2 conditions. So now we already know, and from part A, f of x is continuous at x equal to 0. So now we don't need to prove continuous one more time. We just have to prove the left hand slope equal right hand slope. So let's see if they're equal. So now we're going to do the left hand slope. So let y equal to 3 minus cosine 2x y prime. So we're going to use chain rule over here. Derivative of 3 is 0. The derivative of cosine is negative sine 2x. And then the derivative of the 2x is 2. So we simplify. We get positive sine 2x times 2. You can rewrite it over. So we got left hand derivative at x equals 0. We don't forget to substitute. So we get sine 2 times 0 times 2. So it becomes sine 0 times 2. So we know that sine function look like this. So it's going to be 0 times 2 equals 0. So the left hand slope equals 0. Now we're going to do the right hand. So we get y equal to ln for x plus 1 plus 2. So we're going to do 1 over u times u prime for ln, and then derivative for 2 is 0. So we're going to get 1 over 4x plus 1. The derivative for the u is 4. So now it's 4 over 4x plus 1. So at x equal to 0, don't forget to do substitution for so the denominator will be 1. So we got 4 over 1, which is 4. So now we had left hand slope and right hand slope. They are not equal. So we say left hand derivative not equal to right hand derivative at x equals 0. So f of x is not differentiable at x equal to 0. So because the left hand derivative not equal to right hand derivative, so therefore it's not differentiable. Now let's go to part C. Part C is that express f of x as a piecewise defined function. So now we are going to find f prime of x, which is a derivative. So based on your part B, we already found the derivative of this one, that is sine 2x times 2. So we put sine 2x times 2. You can swap the order. And then for this one, you got 4 over 4x plus 1. So now we just have to determine the domain. Because fx is not differentiable x equal to 0. F prime of x does not exist at x equal to 0. So we exclude x equals 0 from the domain of the f prime of x. So we get x less than 0, x greater than 0. So we finished 3C. Now let's go to number 4. Number 4. Number 4, you have a piecewise function again. So the question asks you, is f of x continues at x equal to 1? Justify your answer. So we're going to find our left-hand limit. Don't forget the correct notation. So 2 thirds times 1 plus 7 thirds. And then we do our right-hand limit. So our left-hand limit equal to right-hand limit. So we can say the limit as x tends to 1 equal to 3. And then you define the point value. The point value equal to this part over here, so which is also 3. So the limit equal to the point value. So f of x is continuous at x equal to 1. So we finish part A. Now let's take a look at part C. Part C, the question asks, is f of x differentiable at x equal to 1? So we also say that for differentiable, you had to satisfy two conditions: continuous, and then left-hand slope equal right-hand slope. So from part A, f of x is continuous at x equal to 1. So now we're going to do our left-hand slope and right-hand slope. So our left-hand slope equal to 2 thirds. So now let's take a look at our right hand. So we got y equal to square root of 4x plus 5. So let's rewrite. Now we're going to use chain rule to find the derivative. We bring the half to the front, and then 4x plus 5, 1 half minus 1. And multiply the derivative of the inner, which is 4. And now we simplify. 1 half of 4 is 2. And this we get negative half. And then we're going to rewrite it. Negative half. So it'll be 1 over square root of 4x plus 5. And then we got 2 square over square root of 4x plus 5. So at x equal to 1, the right hand derivative equal to, so we get 2 over square root of 4 times 1 plus 5. 2 over square root 9, that will be 2 thirds. So they are equal. So now we can say that f of x is differentiable at x equal to 1. Both conditions met. Continues at x equal 1 and also the left-hand slope equal to right-hand slope at x equal to 1. So definitely f of x is differentiable at x equal to 1. So we finished part B. Let's take a look at part C. So part C. express f prime of x as a piecewise defined function. So we know that f prime of x is going to be a piecewise function. So based on our part B, we found the derivative. For the first piece is 2/3. For the second piece, it will be 2 over square root of 4x plus 5. Now we're going to determine the domain. We say that because f of x is differentiable at x equal to 1, f prime of 1 equal to the slope, they equal to each other, which is 2/3. So we include x equal to 1 in the domain of f prime of x. So we're going to have equal. So we finished number 4. So for the video number 2, I am going to continue with finding limit. I'm going to review the L'Hopital's rule.